Salam to all learning fellows. Hope so you will be fine. And today we are discussing about derivatives, rules and formulas. Derivative, rules and formulas. Okay, we are just discussing here basic things, just like how to differentiate and what are the formulas which will help to differentiate any function, either it is algebraic, either it is trigonometric. First of all, you have to know about derivative of constant function, and you have to remember that constant functions have no change, so derivative of constant function is 0. And if we want to check the derivative of algebraic function x, then it will be 1. And if derivative of higher powers, for example algebraic function or polynomial having degree n, then what is the rule? N is coming at start, then reduce 1 power of x, so that is the derivative of higher powers. After that, if we want to find the derivative of 1 over x, we just need to differentiate it with respect to minus 1. So what will be the change? Minus 1 is at start, reduce 1 power in x, so already minus 1, then reduce minus 1 also, it will become minus 1 x square, which is equal to minus 1 over x square. So remember that derivative of 1 over x is equal to minus 1 over x square, minus 1 over x square. Now let's do some more formulas. Next formula is related to the square root of x. Square root of x, we just need to differentiate, just like power rule, d over dx, x power 1 over 2. What we do, last 1 over 2 is at start position in x power 1 over 2 minus 1, so we can get 1 over 2 x power minus 1 by 2. Here x power minus 1 by 2 becomes positive when it will be in a fraction, so that is the derivative of x square root 1 over 2 square root of x. Now we want to discuss about if constant is multiplied with a function. If constant is multiplied with a function, how we differentiate it? We just do constant out of the derivative and take the derivative of x fx, then we get the derivative of fx, and symbolically we can write in Lagrange notation, that is known as Lagrange notation. So constant is out of the derivative, and after that the next derivative rule is, if two or more functions are adding or subtracting, then what will be the derivative? So it's not a big deal, we just do individual derivative of fx as well, plus minus as it is, and individual derivative of g of x, and ultimately we can get f derivative of x plus minus g derivative of x. So that is the rule how to differentiate two or more functions under additions or multiplications, subtraction, for two functions which are in product form, which are in product form, just like this fx into g of x, then we use here product rule. What we can use? Product rule. Product rule helps. The formula, we can know that function as it is, first function as it is, a derivative of second function, plus multiply, change into plus, then again derivative of first function, second function as it is. We can explain it in examples, but remember that in example we just do, there are two functions, we can say that x sine x, we just do that first function as it is, derivative of second function, plus second function as it is, derivative of first function. As we know derivative rules, x as it is, derivative of sine is equal to cos x, plus sine x as it is, derivative of x is equal to 1. So that is the answer. Next we can do some more formulas. Now we can discuss about quotient rule. D over dx, function which are in quotient form, in a division form. How can we differentiate the functions which are in fraction? Very simple. The denominator functions square, and again denominator function as it is, derivative of numerator function. Here minus, we can take minus, and now derivative, without derivative fx, and derivative of denominator function g of x. So that is the rule which gives us g of x, f prime of x minus fx g prime of x over g of x whole square. That is the rule to differentiate numerator and denominator function. So hope so you can understand. Next one we will discuss about composition of two functions. Product and composition are two different functions. For example, f of g of x. In a composition of function, we just do chain rule. But we can use chain rule. But in product form, we can use product rule. So chain rule is for composition operation, and product rule is for product operation. How we can differentiate? It's a very simple way. We just differentiate the whole function g of x as a composition, then we can differentiate again g of x, which we can take as an input of a function f. So that is the rule how to differentiate. In brief way, we can say that d over dx of f at g of x, or you can say that that is the input, d over dg of x. Okay, now that is happened. Now we can differentiate dg with respect to dx. So here we can say that df over dg into dg over dx. That is known as chain rule. That is known as chain rule. Is it okay now? Okay. Next, there are some more formulas which we need to clarify before going on the exercises. After composition, there is a function of inverse. If there is a function just like this, it's mean we are differentiating 1 over fx. 1 over fx. Okay? To differentiate such type of function, we just know the rules. What is the rule? You can understand it by taking quotient formula. Fx square, fx as it is derivative of 1 minus, now 1 as it is derivative of fx. Is it okay? So which you can understand derivative of f, again minus, because this is 0, constant function becomes 0, so minus as it is derivative of this function, and fx whole square. In short, we can say that minus f derivative of x over fx square. That is basically the derivative of this function. Is it okay now? And last formula which we can discuss today, derivative of f prime of x, it's mean f inverse of x. What we can do is just 1 over f derivative of f inverse of x. That is the formula, and it's up to you. You can tell in a comment how we can differentiate and get the desired formula. Today we are completed the formulas of derivatives, basic formulas. There are so many formulas which we need to discuss, and hope so we will discuss in detail in coming lectures. Make sure you can subscribe my channel for more videos. Thank you so much.